And so, hello everyone. Today I will solve and explain you the problem from our homework, and this is our problem. In this problem, we need to find the total kinetic energy, and let's read the statement of our problem. And in our problem, small particles with the same masses m and charges q and minus q move without friction along narrow straight canals intersecting at right angles located in the horizontal plane. At the same time, it turned out that in the process of further movement, the distance r between the particles remains unchanged, and find the total kinetic energy of the particles. So in this problem, we need to find the total kinetic energy. We need to find the total kinetic energy. And let's break this problem down step by step. The two particles are moving along straight line canals which are perpendicular to each other. This means one particle is moving along the x-axis and the other is moving along the y-axis. And their mutual electrostatic force is the only interaction affecting their motion. And to understand their motion, let's analyze the forces acting on each particles. The force between the charges is given by Coulomb's law. So I wrote the Coulomb's law, and since this force acts along the line connecting the particles, we break it into components along the x and the y axis. And at first we need to define the situations in these two axes. And first let's solve the problem along the x-axis. Along the x-axis, our F force will be equal to ma, and we know that this is a Newton's second law. This law is fundamental in classical mechanics and allows us to solve problems related to the motion of bodies, determining the acceleration, force or mass of an object based on the given parameters. And according to this law, our F equals to ma will be equals to F cosines alpha, and here if is given by Coulomb's law, and let's write this equation. If x is equals to kx square over r square, and our Coulomb's law acts along the radial direction r, and if we project it onto the x-axis, we have the equation q square over r square cosines alpha will be equal to ma on the x-axis. And then moreover, if we find that cosines alpha equals to x over r, and let's write this equation. Cosines alpha is equal to x over r, and after we found that cosines alpha equals x over r, and then we will substitute it into our equation. We get the equation kq square over r square multiplying by x over r equals to ma on the x-axis. And then from this equation, when we solve for a, we obtain the final expression for the acceleration. And let's write our final expression for the acceleration. Our ax will be equal to q square x over r square cube. Then after this, let's solve the problem along the y-axis. Let's solve along the y-axis. Our sinus alpha will be equals to y over r, and then we work similarly as we work along the x-axis. Our f on the y-axis will be equals to f equals to m a y. Let's write this f equals to m acceleration on the y-axis, and this equation will be equals to fy sinus alpha. Then we will put the kq square over r square instead of our fy, and then we will get the equation kq square over r square. This is, we know, this is our Coulomb's law, and sinus alpha will be equal to m a y. And then we can write as kq square over r square multiplying by y over r. Y over r is our sinus alpha, will be equals to m a y, and then y kq square over r cube will be equals to m a y. And in this equation, if we find the final expression for our acceleration on the y-axis, we can get the equation a y is equals to ky q square over r cube over m. So this is our acceleration on the y-axis. R remains constant means that the motion of this virtual particle is constrained to a circle, and then we can write as x squared plus y squared is equals to r squared. Since r is fixed, we conclude that the accelerated particle moves in a circle with radius r. This allows us to treat it as uniform circular motion. Because the potential energy of the system remains constant, the total kinetic energy of the system is also constant. Using energy conservation, we find that sum of the squares of the velocity components is also constant. V square equals to Vx square plus V and Y square. And let's rewrite the equations. In this case, on the x-axis for the acceleration, our x acceleration will be equals to kq square x over r cube, and our acceleration on the y-axis y-axis will be equals to kq square y over r cube. And let's write the acceleration for the system. This acceleration will be equals to a equals to kq square r divided to the r cube. And by these equations we get the equation that our acceleration equals to kq square over r square. And this is the final expression for our acceleration in our system. And then after this, let's work with finding the kinetic energy of our system. And at first, let's write the main formula of the kinetic energy. Our kinetic energy for the system is equals to mv square over 2. And then after writing this formula, let's calculate the total kinetic energy for the system. For this calculation, we need to the velocities on x and y axis instead of our v for the system. And let's put this a kinetic energy is equals to mv square over 2 is equals to m over 2, and let's write the vx square plus vy square instead of v square. So let's write this equation: vx square plus vy square. So After these equations, after writing this equation by using the formula of the acceleration for the circular motion, we can find our velocity square is equals to acceleration multiplying r, and let's put this equation for our system, and then after this our m over 2 multiplying ar will be equals to m over 2 multiplying k q square over m r square, and multiplying to r. And then after these equations, all of these equations, we can find that our kinetic energy is equals to k q square and divided into 2r, and this will be our the final answer. And the answer is our problem is a kinetic energy is equals to k q square over 2r, and this is our final answer for the problem. So I hope this explanation was helpful. If you have any questions, feel free to leave them in the comments. Thanks for watching and see you in the next videos. Goodbye.